Okay, guys, we're going to start electrochemistry. This is basically how batteries work in your cell phone, in your car. They are both types of cell at different times, so it's kind of an interesting topic. It does have a lot of practical applications. If you have gold-plated or silver-plated jewelry, this is how it happens, is electrochemistry. And it's really kind of interesting. So, your first worksheet is just getting vocabulary down and the equations. So I've written out for your first worksheet all the vocab I want you to know from this unit, and I've asked you to write out the equations. When I ask you to write out the equations, I also want you to write out what the variables are and if there's any constants, so that you have one place where you look to find an equation that you might need to solve that. We are going to talk about balancing redox equations, and you're going to have to take some notes on this. So hopefully you did your notes Cornell style, so you have some room to write what I add. I will probably do a couple of videos on just balancing redox equations. So we're going to be in this unit for a little bit. So let's get started. Electrochemistry is the study of the interconversion of electrical and chemical energy. When we make a bond, we're storing energy. When we break that bond, we're getting that energy back out. And that's how electrical chemistry works. And it involves transfer of electrons. So one substance has to give up electrons and the other one's going to take them in. So this generates a flow of electrically charged particles, or electrons. So electricity is the presence and flow of electrical charge. This is how the lights at your home work, how you can charge or run your computer with either being plugged into the wall or not plugged into the wall. Those electrons are coming from somewhere. So electrons or ions may carry the charge. Whenever we have charge or electrons going in one direction, there must be an equal amount of charge going in the other direction. So it's really interesting. So here we see some examples from nature and everyday life. Lightning is electricity. We can get electricity out of batteries. And we all know that terrible feeling in the winter when you walk across the carpet and you go to grab the doorknob and you get that nice electrical shock. That's all electrochemistry. So some words that I'm going to go over. Of course, you're going to get a whole lot more words, and I'll have them all be ready to explain them to me. So current is the rate of flow of charge, and the unit for that is the ampere, or amps. And so when we have electrical charge that is flowing, we're going to talk about current. So electrical current that follows in a path is called an electrical circuit. The flow of charge is generated by an electrical potential difference or potential between the 2 points in a circuit. So one place has extra electrons, the other place wants those electrons, and the electrons will flow from area of high electron density to an area of low electron density. Potential is the ability of an electrical field to do work on the charge. That means that they can move that charge over a distance. And the unit for potential is the volt. So now into the chemistry part, because that was kind of physicsy and it was getting me a little nervous. So oxidation is the loss of electrons. Electrons are produced or generated. They are a product of the reaction, and the species is oxidized. You will see in the book words like oxidizing agent and reducing agent, and we no longer talk about those for AP chemistry, so we're going to skip them in this class as well. Reduction is the gain of electrons. And electrons are consumed, or they are reacted in that half reaction, and the species is reduced. So if it's gaining electrons, it is reduced, and it's the reduction half reaction. Reduction reactions or redox reactions are an oxidation coupled with a reduction reaction that are both occurring simultaneously, and they have to have the same number of electrons being generated and being consumed. So, like I said before, oxidizing agent, reducing agent, we're no longer going to discuss. The little mnemonic that I use for this is Leo goes grr. You can use oil rig if you prefer, whatever you like. Leo goes grr. The loss of electrons is oxidation. And so that would, and I would probably write in my notes here, that would be electrons as a product. Gain of electrons is reduction, and I would write here, electrons are reactant. So, the assignment of oxidation numbers allows one to determine what is being oxidized and what is being reduced. For elements and monoatomic ions, the oxidation numbers are just the charge on that species. Now here I'm going to pause with what the slide says, and I'm going to add some things that you need to write down. So you'll want to start and stop as I go through. The first group, or first element that you should have written down in your notes is that fluorine, F, is always -1. That's rule number 1. Rule number 2, oxygen or oxide is almost always -2. And its exceptions are when it's with fluorine or if it's in peroxide, O2 2-, then it's -1. If it's with fluorine, then it's +1. Group 1 elements are always +1. Group 2 elements are always +2. Group 3 elements are usually +3. Group 5 elements like nitrogen are usually -3. The oxygen group, the chalcogens, are almost always -2. And the halogens are almost always -1. The noble gases do not have oxidation numbers because they rarely react. Everything else will have to be determined by context, and I'm going to go over a video on that and assign that for you later. So I've just gone through the rules for the elements and what they normally are. I'm going to talk about rules for assigning oxidation numbers in that other video where I go through and do some example problems for you. So that will be under the problem videos for Electrochem. So oxidation numbers are generally small whole numbers, but they may be fractional. We will not deal with any fractional ones, so you're getting off lucky there. So oxidation results in an increase in the oxidation number, or it gets more positive. So here copper is a solid, and all elements have an oxidation state of 0. Once they lose or gain electrons, then they have a charge, and they are called ions. So copper solid will lose 2 electrons, giving us copper 2+ plus 2 electrons, and this would be an oxidation reaction. Reduction results in a decrease in the oxidation number, or it becomes less positive or more negative. It does not have to become negative. It does not have to be positive. It just has to change to decrease the oxidation number for reduction or increase it for oxidation. So if silver gains 2 electrons, 2 atoms of silver gain 2 electrons, then it becomes silver metal. So I'm going to have you write this down, and I'm going to go through some example problems in the next couple of days so that you get more comfortable with this. This is a little difficult, and I understand that. Once we get through oxidation half reactions and how to balance them, the actual work of doing electrochemistry gets a lot easier. But we have to be able to do the half reaction balancing method to be able to get to things like cell potential. So the first thing you want to do is assign oxidation numbers to all the species in your reaction. You're then going to look for something that has a gain in oxidation number and something with a loss of oxidation number, and that will give you your half reactions. So you're going to balance one half reaction in terms of electrons and charges and atoms, and then you're going to balance the second half reaction in terms of electrons and atoms. Then you're going to have to get those two half reactions that have the same number of electrons being transferred, so that when you add up your two half reactions, you end up with no electrons left over. So every electron that's generated in your oxidation reaction has to be consumed in your reduction half reaction. So once you add those two up, then you're going to balance atoms and charges, and we're going to go through all the gory details there. So I am going to stop here, and we will continue on tomorrow. Thanks for watching.